Yes, good morning, all of you. This is Nagasri Physics Academy, Mancheriala. Today, we are discussing about momentum of inertia. The first, today, we are discussing two problems. One is the first problem. So that means 4L length of rod is bending as shown in the diagram. So this means this is the L length of rod. This is the L length of rod. This is L length of rod. This is L length of rod. Totally 4L length of rod is bending like this. Each rod mass is also M. Here mass will be concentrated at its center. Here mass will be concentrated at its center. Here mass will be concentrated. Mass will be concentrated. And the axis is passing at a point of O. Here about the system, about this axis, this is about the axis, and about this axis entire the system is rotating. Then momentum of inertia we are calculating about the system. First, this is the rod 1 and rod 2, and this is the rod 3 and rod 4. Rod 1 and 2 is the inner shape of the arrangement. Inner shape of the arrangement. See here, about this axis, the first rod, about its end, the system is rotating. The rod about its end, axis consideration is there. About the first rod, momentum of inertia, I1 is equal to, so ml square by 3. So L is the length of the rod. At one end of the rod, axis is considered its momentum of inertia ml square by 3. And the other end of the rod, so second rod is there. Its momentum of inertia about this axis. Always we are calculating momentum of inertia about this axis. For second rod, momentum of inertia I2 is equal to ml square by 3. This is the formula for, so axis is at its one end of the rod. Axis is passing at one end of the rod. The momentum of inertia formula ml square by 3. So totally the momentum of inertia from the first rod ml square by 3, from the second rod ml square by 3. But momentum of inertia about this third rod, so we are using the parallel axis theorem. About its center, one of the axis is considered. And how much distance is there? So from the center to from axis, this is the distance. How much distance is there? Here given the question, this is nothing but 90 degrees. Here the length is L by 2. See here, half of the rod mass will be concentrated. Here mass is concentrated. Mass is concentrated. Now from here to here, we are calculating the distance. How to calculate it from here to here distance? This is the right angle triangle. So for this right angle triangle, we have to draw this one. So distance square, hypotenuse square is nothing but, this is the hypotenuse. Hypotenuse square is nothing but, from this point to this axis distance, we are considered d. So this is the hypotenuse square is side square plus side square. So therefore, L by 2 whole square plus L square. Now d square is equal to L square by 4 plus L square. Now this is 5L square by 4. Now we are using the parallel axis theorem. This axis is passing through center. So third rod momentum of inertia we are calculating. This is nothing but third rod, its length is nothing but L. Entire mass is concentrated center. So third rod momentum of inertia, we are using the parallel axis theorem. What about the parallel axis theorem? I3 is equal to IC plus MD square. So what is D square here? 5L square by 4. D square here 5L square by 4. Already we calculated 5L square by 4. See here, momentum of inertia about the third rod, about this axis, with respect to this axis. So this is considered AB axis. With respect to the AB axis, we are calculating the momentum of inertia. So simply I3, that means third rod momentum of inertia with respect to the AB rod. So that means IC, that axis is passing through center and momentum of inertia is nothing but here ml square by 12 plus m into d square already we calculated that what is the value of the 5l square by 4. So simply the momentum of inertia I3 is equal to ml square by 12 plus 5 ml square by 4. So therefore the momentum of inertia for this third rod I3 is equal to, so 12 is take LCM. Here ml square, so 4 3 times is cancelled, 3 into 5. 15 ml square. So therefore, I3 momentum of inertia, so 16 ml square by 4. So 4 times and 4 3 times. So finally, 4 ml square by 3. For this third rod momentum of inertia, this one. And similarly, the fourth rod is also same formula we are using. For the fourth rod momentum of inertia, see here 4 ml square by 3. Now the total momentum of inertia of this arrangement with respect to the AB axis, I is equal to I1 plus I2 plus I3 plus I4. So therefore, the total momentum of inertia I is equal to I1 is nothing but already we calculated ml square by 3 plus with respect to the second rod with respect to the AB axis momentum of inertia ml square by 3 plus I3 is nothing but what we calculated, see here 4 ml square by 3, 4 ml square by 3 plus similarly I4 is also already calculated 4 ml square by 3. Therefore, the total momentum of inertia ml square by 3 ml square by 3 2 ml square by 3 plus 4 ml square by 3 plus 4 ml square by 3 8 ml square by 3. Therefore, the net momentum of inertia 10 ml square by 3. See here in the given question, so 10 ml square by beta is there. Therefore, the beta value is 3. I compare this one, the beta value is 3. This is the total calculation, total arrangement. So, I1 is nothing but similarly ml square by 3. This is the brief explanation about this problem. Rotational dynamics, this is the advanced problem. So, total momentum of inertia 10 ml square by 3 for this arrangement. 4 rods are there. Its total length is 4L and total mass is 4L. Okay. Thank you all of you.